Hey everyone, hope everything's all good. Unit 4 tests, first test of second semester material coming up here. So let's use this review as you all did to succeed in the first semester. Allow me to share my screen, get the review questions up there. Remember, practice, practice, practice. The more you practice this, not just watching me do it, but doing it yourself. Um, a lot of this will probably have to be done in class or at least with a calculator at home, because most of these problems call for the use of a calculator. Just making sure everything is being recorded. And if it's not being recorded, then you wouldn't hear what I'm saying anyway. Stop me if you've heard that one before. Okay, remember, pause, rewind, go slow, go fast, do what you got to do to be as successful as possible on this upcoming test. Okay, so if I look at this, 3 to the power of x, 3 is, ooh, gotta turn my pen on so I'm not changing slides every time I go to write something. Okay, 3 is your base, that is more than, okay, the base is more than 1. So we're going to have growth here. Okay, so that would mean that we would start not at 3, but at 1. 3 to the power of 0 equals 1. So that takes care of my y-intercept. So I'm skipping ahead to the y-intercept because I want to make sure I have some place to start on my graph. So if I go 3 to the power of 0, it's 1. 3 to the power of 1 is 3. 3 to the power of 3. You should mark the parts that you can on the graph. Don't make it just be a line that goes up randomly, right? So 3 to the power of 2 is 9. So I can graph all these accurately, okay? Before that, it can kind of look like that. So what did I just do? I just graphed 3 to the power of 0, which is 1, 3 to the power of 1, which is 3, 3 to the power of 2, which is 9. Now, I know 3 to the power of negative 1 is 1 over 3. 3 to the power of negative 2 is 1 over 9. But, we're not really going to be able to tell that. But we should be able to know it. So domain, it's always going to be this. Domain is all real numbers. My range, that's saying what y values are possible. Y values, it's not all y values because we have an asymptote at 0 here. So our values are all going to be greater than 0. In behavior, as x goes up, that's all this is saying. As x goes up, what's happening with y? Well, the y value is also going up. Okay, right here, as x goes down, as x goes down, the y value is getting closer and closer to 0, but never crossing there. So my y value is heading toward 0. It's never going to get there, but it's heading toward it. Okay, because my asymptote is at y equals 0. And most of that stuff is the same, even when we're talking about, I'll even change colors for decay. How do I know this is decay? Because 2/3 is between 1 and 0, right? So my base is 2/3, but here's the thing, 2/3, if I took 2/3 to the power of 0, that's still going to be 1. So regardless of the fact that now I'm going down, I'm decaying, I still am going to start with a y-intercept of 0, 1. Okay. Now, graphing here, 2/3 to the power of 1 is 2/3. 2/3 to the power of 2 is 4/9. But I don't expect you to know exactly what 2/3 and 4/9 mean. looks like, what I do expect is that it gets closer and closer to zero and then has an asymptote there. Now, don't just draw a line straight up, because especially with like 2/3, like it goes very slowly backwards, right? Like if I went to 2/3 to the power of -1, that's just 3/2, aka 1.5. Okay, if I'm flipping these, right? These should be related. 2/3 to the power of -2 is going to be 9/4. Well, what is 9/4? 9/4 is just a little more than 2. It's 2.25, right? So we're going up slowly here after graphing a couple of them. And then we can have like a more subtle curve there. All right, so here's the good thing though. The domain, it's always going to be all real numbers. That's a gimme on the test. It's never going to change. Same here with the range. Range is going to be y is greater than 0. So even though it's going in the other direction, it's still never going to cross 0. This is what needs to change though. As x goes up here, this is when my y approaches 0. Okay, all this question is saying is when the graph goes to the right toward infinity, we go toward 0. Now, as it goes to the left, as we go down into the negative portion of the x values, my y values, that's when they're going up. They're going toward positive infinity. The asymptote is still at y equals 0. Okay, so really just the end behavior is really the only thing that's going to change, but just please actually look at the graph and see where that end behavior is. We can flip to the next page on my review. Right, your formulas, you're going to have these formulas on the test. Okay, so use them. Use them. Make sure you're not just staring at those formula sheets. Actually use them. Okay, the principal, that's what you start with. Your rate, especially with these compound interests, make sure that you're taking your rate, converting it to a percentage, and dividing it by the amount of times that that percentage is happening over the amount of time, right? So keep these in mind. Use lots of parentheses in your calculator. Okay, so 20,000 in the bank, that's what we start with. So that's our principal. 4.5% interest. Okay, 4.5, we are converting from percentage to a decimal. So you need to divide by 100, which would give you 0.045. Okay, we're adding here. So we're going to add that to 1. So my rate is going to be 1 plus 0.045. Okay. My n is it says 12 times a year, right? So like every month this is happening, and this is happening for 5 years. So really, after you figure out this, the numbers to put in here, you just got to look, okay, I'm going to take my starting value. I am growing. That's why I'm going up with my rate. That rate is not happening that rate every time. It's happening 12 times in a year, once per month. So just put that whole thing in your calculator. Put an extra set of parentheses here so that your calculator doesn't accidentally take the wrong thing to the wrong power. Okay, and then NT should be 60. Why is it 60? Because 5 times 12 equals 60, right? This was happening every month for 5 years. There were 60 months in that 5-year period. Once you calculate that in your calculator, you should have $25,035. Round that to 92 cents. Okay. This question isn't asking it, but it's good to know that if that's my final amount, if that's my final amount, you take that final amount, 035.92. The difference between the final amount and your initial amount, right? Like what you paid versus what the price tag said. Okay, that is your interest in this case, $5,035.92. The difference between them is the interest. That's how the banks make money. That's how people who lend you money, why they do it, to make the interest, not just out of the kindness of their heart. Okay. All right, now interest also has its benefits to you, right? When you have things that are going to earn interest for you. This actually is on my sheet, but I hadn't done this one for whatever reason. So this is proof. You need a calculator. I'll be right back. I need my calculator. Okay, I've got my calculator. All right. Okay, so Maya is puts 2000. So again, let's set up our equation again. Make sure we have our A, P, R, N, and T. I had accidentally posted, I don't need this equation. That's for the next problem. That was my problem there. Okay, the principal. Maya put $2,000 into the account. The rate was 6.25. If we divided that by 100, it would be 0.0625. There's a big difference between that and 0.6 or 6.0. So be careful there with the percentages. Compounded quarterly, that happens once, or sorry, 4 times per year, just like there's 4 quarters in a dollar. All right, so my rate is 0.0625. I'm going to add that to 1 here eventually. The N is 4. And the T, it's happening for 15 years. Okay, so 2, this asks for the balance. So we had $2,000. We're adding 1 plus 0.0625 over 4. Keep those in parentheses. Close the second set of parentheses, and you're going to have 15 4 times 15, which is 60. So again, we're going to the power of 60. Wasn't the plan to do this. All right, so using my calculator here, putting the first set of parentheses, 1 plus, starting my second set of parentheses, 0.0625 divided by 4, close both sets of parentheses, go to the power of 60. And good for Maya. After 15 years, her account has gone from $2,000 to $5,070.29. Okay. Now, the question doesn't ask for it, but so 5,000. It asks for the balance, so that's what this question is asking for. But if we asked for the interest, we would do 5, the new amount minus what we started with, and our interest is, so this is the interest I'm calculating here. The interest is $3,070.29. Okay, write a exponential equation for these ones. We have an initial value, right? So that's my 250,000. My rate here, again, we're increasing in value, so 2.25% plus 1. So we need to take 1 plus 0.0225, which would be 1.0225. My variable here, this is happening every 15 years. So you need to take years, however many years you have, and divide it by 15. Okay, so I don't need you to calculate anything. I just need you to put the equation it's asking for 250,000 times 1.0225 years divided by 15. Now, if the question were to say, okay, so how much is this home valued at in 12 years, then I would need you to plug in, 12 over 15 to actually calculate that. I would need you to plug, if I said, how much is it worth in 20 years? You need to plug in 20 to the Y and actually find what's the value there. Okay, so both of these are just asking for you to give an equation 7.4%. That's like saying 0.074. Be very careful with those. Okay. We are decreasing in value, so we need to do 1 minus 0.074, which is 0.926. So it's really happened. Decrease 70 by 7.4% leaves you with 92.6% of what you started with. This is happening every year, so we don't need to change it. Okay, so 32,000 times our rate to the power of however many years go by. And then we could just plug in the number as you get the years. If I asked you to evaluate how much that is worth in a certain amount of time. Okay. I think give you as much, there's not as much room on your paper as I have on my screen, so I'll take advantage of it and hopefully, you guys can understand what I'm doing here. All right, so basically if we rearrange this formula, we would say, all right, log base 5, 265 equals X. So we don't have anything. That is what's going on. We're trying to figure out 5 to the power of what would be 265. But we learned the other day how to solve these. We're going to log both sides. So log 5 to the power of X equals log 265. Okay. So what I'm going to do here is in order to find out X, you divide the X comes down, right? And so we have X log 5 equals log 265. Divide both sides by log 5, according to our equation up there, right? And now we have our answer is going to be log 265 divided by log 5. Don't forget, use your parentheses. If you're not sure about your parentheses when you're doing these, call me over. Let's make sure that the parentheses are all straight. We don't want some computing error to happen on accident. All right, we get X equals 3.467. If you got a different number than that when you tried it, call me over. Let's see what happened with the parentheses. Okay, base 10. These ones are nice because the buttons on our calculator are actually already set to base 10. So we actually don't need to do this rearranging of both sides. When I do log, because if I do log base 10, 80 equals X, if I just hit the button on my calculator that says log 80, the calculator is assuming a base of 10. So log 80 is going to give me X. And log 80 is 1.9. Let me see what it is exactly. I think that's rounding. It's a little more than that, right? But if you're trying to test these, okay, is 10 to the power of 1.9 equal to 80? Well, I know 10 to the power of 2 is 100. 10 to the power of 1 is 10, right? So I at least know I'm in the ballpark where I should be, and that answer makes sense. Right, so if you get something that doesn't make sense, plug it back in and see if it works. Okay, another log problem with base 10. Okay, so base 10 really helps us because base 10 is what we already know to be in the calculator. Okay. So basically what this is saying, 10 to the power of something equals 1,000. Okay. So I want to know what log base 10, 1,000 is going to equal. And whatever that equals is going to give me x minus 2. Okay, log of 10,000. So 10 to the power of what gives me 1,000? That would be 3. So 3 equals x minus 2. Now you just have a one-step equation to solve. And even if that process doesn't make sense, let's look at this. 10 to the power of something minus 2 equals 1,000. Well, I know 10 to the power of 3 is 1,000. So how do I make something minus 2 equal 3? How do I make this part of the equation equal 3? Well, 5 minus 2 is 3. Okay, so all the log stuff, you know, I know it's tough, but we should still like have our logic with us. Okay, now we have one where we essentially have to log both sides. There's not really some logic to get us there, right? Unless you have 2 to the power of stuff memorized. I know I don't. So let's log both sides. Log 480. And then log 2 to the power of 3x. The beauty of logging and having an exponent is that it's going to help just bring this down. So what we have now is log 2. And I'm going to put it in parentheses because that's just like one number. Okay, when you hit log 2 on your calculator, you're going to get a number. Okay, that number is being multiplied by 3x. Log 480, again, that's just a number. Now, 3x and log 2 are together. We need to separate them. So let's get rid of the log 2 on this side. And now we have 3x equals log 480 divided by log 2. And I believe that number, I'm going to leave it as log 480 divided by log 2. Right? Like that's just one number. And that number ends up being 8.9-ish, right? When you divide, now we have 3x's. We don't want 3x's. We want one of them. Divide it by 3. Now you have x equals, I believe it was 2.97. Okay, now if your answers were a little off from that, maybe you rounded in some different spots, but it should be close to 2.97. All right, now hopefully in class, I reminded you to do this, which is we're talking about lift stock here, and it says it's increased exponentially, but actually, when we look at the price here, it went from 1,560 to 1,390. So it's actually decreased. So at least note that we are decreasing. We're looking for these numbers to go down. Okay, so what was the growth factor over the 4-month period? To find growth factor, you take the new number and divide it by the old number. That's just in general. Okay, that tells us what's happening. Despite how long it's taking, if you take what's new, and our new price is 1,390, divided by the old, this is going to tell us what happened in order to get it. It's telling us what percent, essentially, that the new number is of the old number. All right. So what that gives us is 0.891. So basically, lift stock is worth 89% of what it was worth 4 months before. All right. So that's over 4 months. That's what happened in 4 months. Okay. What is the growth factor each month? Well, I take that number, that 1,390 over 1,560, which is 0.891. Now that's rounding. I'm keeping this in parentheses because I don't necessarily want to round that. when I'm going to take it to the power here. But let's think if I just had a 4-month period and I want to know what happened in 1 month, okay? I want to know what happened in one out of those 4 months. So I take this number and I take it to the power of 1/4. And that gives me approximately 0.97. So if I have 89% or close to 11% decline in 4 months, that was after having basically a 3% drop per month. Right now, 3 times 4 is not 11, right? Because this is exponential, it's not going to be just as simple as dividing by 4. That's why we need to go to the power of 1/4. So you would have gotten this roughly the same answer if you did 0.891 to the power of 1/4. Still would have got 0.97. Okay, so write an equation for the function that would compute the price of lift stock. Okay, so we need to take what we started with, $1,560. And what's changing, if it's saying compute the lift stock after every month, right? So take the monthly change. Okay, so that's monthly, 0.97, and take it to the power of months. Now, there's another way you can do it. Okay. You can also say, okay, I started with that amount and 0.891 is what changed in those 4 months. And if you use that rate, that's fine. But then you have to take the amount of months that you get and divide it by 4. So either one of these would be acceptable answers, but you need to make sure that, if you're using the monthly rate, then you're taking it to the power of 1 month. If you're using the 4-month rate, then you need to take it to the power. You need to cut those months into fourths. Okay, in the context of this problem, what would F10 mean? That means the cost of the stock in 10 months. What's happening in 10 months? You could also say in September of 2019. You can even calculate. If you calculate, this isn't asking for you to calculate it. What this is asking to do is just tell me in words what this stuff means. Okay. But if you do calculate it, okay, right, we take that monthly change, 10 months. I used 0.97 because I'm going to just take it to the power of 10, find it a little easier that way. I don't have to worry about fractions in my exponent. So basically, if that stock continues to fall, it will be worth $1,169.10 in September of 2019. So that was an older problem in recent times. So I guess we should update that in the past. Okay, we did these in class, but I want to, these were tough problems similar to the ones we just did. So let's just make sure that they are automatic by the time you walk into the test. So again, this is where we started, or not where we started. In this case, we actually are increasing exponentially, right? So we had 2000. So whether you're increasing or decreasing, the process is the same. The new gets divided by the old, which will give you your growth rate. In this case, it's a growth rate, right? You can tell because it's above 1, right? So this stock is going up by 84% over a 20-month period. So what's the factor per month? You would take that number, 1.846. I'll just leave it as its decimal. Take it to the power of 1/20th because you're taking those months, dividing it into 20 parts. And that's your monthly growth rate. Okay, so how would I get this stock, right? It started at $1,430. what's happening per month is 3% growth. And I can take it to the power of X, however many months go by. I can also write this as that starting value. If you did the computation to get 1.846, you went to the power of X divided by 20, your months divided by 20. You could use M for months as well. Yep. All right, growth factor here over the 8-year period. Again, new divided by old. Growth factor, we used parentheses there because we're actually not growing in this case. We're decreasing in value. 3, 7, 4. So new divided by old, right? Just keep that in mind. New divided by old is going to be your growth factor. Okay, so that's what happened over 8 years. So I can take that number, 0.3714. If I want to know what happened every year, right? Consider that 1 year is 1/8 of 8 years, which gives me my growth factor or decay factor. We went down to 88%, so we've gone down roughly 12%. Just like we could before, go with our starting value. If you decide to put the annual, aka yearly rate, that would be great. If you do that, you're going to go to the power of X without dividing your exponent. But if you put the initial value that you computed, 0.3714, you go to the power of X. You just need to break that into 8 parts because that was over 8 years. Okay, instead of writing 0.3714, you can also just put this entire fraction, right? So I guess I can write third option here, which would be to write 35,000 and just leave this as a fraction. If you do this, be careful with your parentheses and make sure that you're closing these parentheses before taking it to the power of X over 8. All right, good luck on your tests.